In a quiet lecture hall at the California Institute of Technology, long before smartphones and viral science clips, a thin man with restless eyes and a mischievous smile stood before a blackboard filled with chalk dust and possibility. His name was Richard Feynman, and although the world would remember him as a Nobel Prize-winning physicist, to his students he was something more dangerous, a man who could make the universe feel close enough to touch. On that particular afternoon, the topic was something almost sacred in physics: the speed of light. Most professors would begin with a number: 158 meters per second. They would say it like a prayer, a constant etched into the bones of reality. They might mention Albert Einstein, relativity, time dilation, maybe a few equations. The students would write it down. Some would memorize it. Few would feel it, but Feynman did not begin with a number. He began with a question. "What do you mean?" he asked, pacing slowly. "When you say something moves." A student raised a hand. "It changes position over time." Feynman grinned. "Ah, but what is time?" The room shifted. Pens paused mid-sentence. And that was how he always did it. He did not answer the question you thought you were asking. He answered the question beneath it. He turned to the board and drew a simple, "Dot this," he said, "is you." Then he drew another dot far away. "This is a star." He connected them with a line. When light leaves that star and reaches your eye, something has happened. Something very specific. But what? Silence. He tapped the chalk against the board. "Light does not take suggestions," he said softly. "It does not ask permission. It moves at one speed, always, no matter who watches." He paused. "And that," he said, "is the strangest thing in the universe. The constant that breaks intuition to understand why the speed of light is so shocking, you must first forget what feels obvious. If you throw a ball from a moving train, the ball's speed depends on the train. If the train moves forward at 50 miles per hour and you throw the ball at 10 miles per hour, someone standing on the ground sees it moving at 60 miles per hour. That is common sense, but light refuses to obey that rule. If you shine a flashlight from a moving spaceship, someone standing still does not see the light moving faster than usual. They still measure it at exactly the same speed, 299, 792, 458 meters per second. Feynman leaned against the desk and let that sink in. "Imagine," he said, "that you're chasing a beam of light." He paused dramatically. "You run as fast as you can. Faster. Faster still. You build a rocket. You go almost as fast as light itself." He drew a stick figure with wild hair and a rocket pack. "What happens to the light?" A student answered carefully. "It should slow down." "Relative." "To you," Feynman's grin widened. "Nope." He slapped the board. "It still moves away from you at the same speed." The room erupted in nervous laughter. "That," he said quietly, "is where relativity is born. Einstein's strange discovery." When Albert Einstein was a young patent clerk, he imagined riding alongside a beam of light. What he realized was devastating to classical physics. If light speed is constant for everyone, then something else must give. Time, space, distance. They cannot be absolute if light's speed is absolute. Feynman did not worship Einstein. He admired him. But he admired the logic even more. "If you assume light's speed is the same for everyone," he told the class, "then the universe has no choice but to rearrange itself." He drew 2 clocks on the board, one on Earth, one on a spaceship. "If the spaceship moves very fast," he said, "its clock ticks slower, gasps, and its length shrinks." More silence. He shrugged. "The universe protects the speed of light the way a bank protects gold. Time slows. Not because it wants to. Feynman hated mystical explanations. Time does not slow down because it's tired. he joked. It slows because it must. If you are moving close to light speed and light must still outrun you at the same speed, then the only way for reality to keep the math consistent is for time itself to stretch. This is called time dilation, and it is not theory. Atomic clocks flown on airplanes tick slightly slower than clocks on the ground. Satellites in orbit must account for relativity, or GPS systems would fail within minutes. Feynman pointed upward. Every time your phone tells you where you are, it whispers, "Einstein was right." But he would then add, almost mischievously, "And the reason Einstein was right is because light refuses to compromise." What is light, really? Here is where Feynman would lean forward, lowering his voice. What is this thing that behaves so stubbornly? Is light a wave? Yes. Is it a particle? Also yes. It comes in tiny packets called photons. Each photon has no mass. None. Zero. And here is the next twist. Because photons have no mass, they must travel at light speed. They have no option to move slower. Massless things cannot sit still. They are condemned, Feynman said once, smiling, to eternal motion. But something even stranger hides beneath that fact. From the perspective of the photon, if such, a perspective existed. No time passes. None. The photon leaves a distant galaxy and arrives at your eye. For us, it may take billions of years. For the photon? No time at all. Feynman let that idea linger like smoke in the air. The universe, he said, is stranger than we are comfortable with. The barrier, no one can cross, the speed of light, is not merely fast, it is a wall. Nothing with mass can reach it. As an object moves faster, its energy increases. As its energy increases, its effective inertia increases. Pushing it harder yields less and less gain in speed. To reach light speed would require infinite energy. Feynman drew a curve that climbed higher and higher but never quite touched the top line. You can approach, he said, but you cannot arrive. He turned and faced the students. Nature has posted a sign, "No trespassing." The illusion of simultaneity. Then came the part that made students uneasy. Simultaneity, the idea that two events happen at the same time, is not absolute. If lightning strikes the front and back of a moving train at what appears to be the same time to someone standing still, a passenger on the train will not agree. For the passenger, one strike happens before the other. There is no universal now. Feynman stepped back. If you and I move differently, he said, we slice time differently. That was perhaps the most disturbing idea of all. The universe does not come with a master clock. It comes with light, and everything else adjusts. The lost lesson years later, one of Feynman's students would say that what made his lectures unforgettable was not the equations, it was the tone. He did not speak as though he had conquered the universe. He spoke as though he were still astonished by it. In one quiet moment near the end of that lecture, he erased the board slowly. All of physics, he said softly, rests on a few simple principles. He wrote one final line. The speed of light is the same for everyone. Then he circled it. From this, he said, comes time travel to the future, comes black holes, comes the structure of causality itself. He paused. But do not memorize it. He tapped his chest. Feel it. Because the true lesson was not about the number 299, 792, 458. It was about intellectual honesty. If nature tells you something strange, you do not argue with nature. You follow it, even if it tears apart your intuition. Why this still matters today. In laboratories around the world, scientists measure cosmic background radiation, detect gravitational waves, and probe quantum entanglement. The constant speed of light remains the backbone of these discoveries. In particle accelerators, protons race at speeds so close to light that time dilation becomes measurable. In cosmology, the expansion of space stretches light across billions of years, and still, always, the speed of light remains unchanged. Feynman would likely laugh at our tendency to treat it as mystical. It's not magic, he would say. It's just the way the universe keeps its books balanced, the final thought imagined standing under a night sky. A photon leaves a star millions of years ago. It crosses vast emptiness. It bends near gravity. It survives cosmic dust. Then, in a fraction of a second, it touches your retina. In that instant, you are connected to something unimaginably distant, and the rule that made that connection possible, the unwavering speed of light, is the same rule that bends time, shrinks space, and defines the edges of reality. Feynman once said that, "The pleasure of finding things out is one of the greatest joys in life." Perhaps the lost lesson was this: the universe does not owe us simplicity, it owes us consistency. And in the stubborn, uncompromising speed of light, we glimpse that consistency, beautiful, strange, and absolute. If you want, I can now expand this into a full 5,000+ word cinematic. Storytelling version, add YouTube title, description, and SEO tags, create high CTR thumbnail, text or generate AI image prompts.